Bites of Pi. Today we're going to cover the second part of classes in depth. We're going to cover static variables and methods, and then we're going to cover exceptions. We'll first start off by defining what static is, and then we'll cover static variables and then static methods. What is static? Static declares a method or a variable to belong to a class name and not to an object instance. For example, the functions from the math class are static. We can use those functions without creating a new math object. So classes, whenever we wanted to call a function in the past for an object, we had to have an actual instance of the object. We create a new instance using the keyword new. But you've noticed here, I can call this here I can use the power function, 3 to the power of 2. And you notice I didn't say new math. I didn't have to say math variable equals new math and then call that variable's power. It's calling a static function pow. I can do the same thing with absolute, and I can do the same thing with max. These are all static methods or static functions that don't need an instance of math in order to call them. The rule of thumb is to think of static as shared. A static variable doesn't belong to an instance. All the instances of the object can refer to the same variable. For example, let's talk about let's create a static counter to our car example. So here, in our previous example, we had a string color where we can store the color of a car. But we're also going to add this static counter. And we're going to kind of go through step by step to show you how color and counter differ. The constructor will set the car's color to whatever comes in. It'll increment the counter and then print out what number of car is getting built. So right off the bat, here's our function again. This is the class car. And we're going to go through this function main where I'm going to create 3 new cars. I'm going to create a red, an orange, and a blue. Before we even start the function, when the program loads up, it'll load up a car and it'll create this counter variable 0. So even before we create any new cars, automatically we have this static counter variable that's related to the class car. It's not an object, it's just the class. We're going to start off by creating a new red car. So here we are at the red car. We're going to go into the constructor. The constructor will create a new red car, and it creates a new color variable. So here in this object, here in space, it has a variable called color, and it's pointing to the string red. I'm going to then increment counter, the shared counter variable, and then we're going to print it out. So here I am printing it out, and sure enough, in the system output, I have car 1. I will return from the constructor, and then I'm going to move on to the next line where I'm going to create an orange object, an orange car. I go into the constructor, I create another object and set that color to orange. Notice I now have two objects, each have their own copy of color, so they have their own instance of color. However, they all share the same counter object. I go to the next next line, and it increments counter here. So I'm not starting off with counter equal to 0. Counter is now 1, and I'm incrementing it. And now I'm going to print it out, car 2. So you can already start seeing the difference, but what this little word makes between the two instance variables. I'm going to return from that function, and then I'm going to create a blue car. So again, I go into the constructor again. I create a third variable, blue. I'm going to increment the counter. So it's a shared counter variable. And I'm going to print it out, car number 3. Notice I still have the first color variable is pointing to red, the second color is pointing to orange, the third one's pointing to blue, but I don't also have 3 counter variables. I only have 1. So this is very key. You might want to, during these videos, you might want to pause and rewind just so you can kind of step through these examples, because sometimes it's kind of hard to grasp the differences between an instance variable and a shared class variable. A static method also doesn't belong to an instance. Because you don't need an instance, you can't access instance variables. So here's a function here, or here's a class car here, and we just for giggles, we're taking our two variables. One is the instance color, the instance variable color, and the other one's the static counter. And I modified this function slightly to the getColor function to static. However, it's accessing this variable color, which is not static, because if I have any variable inside this function, it won't even compile. This color is not static, so it will fail. If I was to try and compile this, it will fail, saying I'm trying to access a non-static variable in a static function. However, I can create a static cars built function, and I can access a static variable. Notice that the counter is static, so this will work. This function will work because counter is static. Let's go through an example where we're using a static function. Now notice this kind of works like math. The math functions, if you notice, right, even before any line of code is run, when it gets loaded into memory, I automatically have my counter variable 0. It's automatically loaded statically. So even before I create one single car, I can call the function cars built. You know, like with math, I could call math pow and then add some functions. But in this case, I'm going to call cars built. So it'll call this static function cars built, and it'll start off with 0. Now it goes to the next line where I'm going to create a new red car. So here I am creating a new red car. Again, I have a shared counter. I'm going to increment counter to 1, then return. Now I'm going to create an orange car, and I'll go to the constructor again, create another variable color, and set it equal to the string color, and then I'm going to increment counter to 2. Finally, I'm going to return and go to the last line where I call the exact same function, cars built, and instead of 0, the variable counter is 2, so I output 2. Now we're going to cover exceptions. When Java runs into problems, whether they're logic or programmatic, it will throw exceptions or errors. For the APCS exam, we'll only cover exceptions. Now in the first part 1, we've already covered null pointer exception, when you have a variable and it's set to null, and you try and access a non-static function for a variable, and it is null. But here's another example where I'm trying to divide by 0. Here you can see at line 6, I'm taking 1 and I'm dividing it by 0 and trying to set it to A. When this program, you notice that line 7 never gets reached. When I start here, it'll try and divide by 0, and you don't see in the output what is A here, because it never got that far. It'll come here, hit the divide by 0, and then fail. You can see as you trace through the stack trace, it's an arithmetic exception that was thrown. It's a divide by 0 error, and then you can see where the error originated. Here it's just originating right here at line 6, and you can see that right here. In the previous example, we chose not to handle the exception. However, you can choose to either trap for specific exceptions using a try-catch block, or throw the exception so another part of the code can handle it. We're not going to cover throwing exceptions, we're not going to cover try-catch blocks, but you're going to need to know how to throw exceptions. And here I am. I'm creating, just for giggles, I created my own custom exception. I'm going to call it, it's an actual Java illegal state exception, but I can create my own custom message. We'll actually kind of trace through that here. Notice when the program fails, there's a stack trace down here below. If you can start from the top, you can see where the program failed and trace each point back from where it first happened. So here I can see that a legal state exception was thrown somewhere, was created, and my custom message here was displayed. I start at the first line and I can go right to the point in code where the error was thrown. Here I can see that it was thrown at line 12. So if I go to line 12, I see, yep, I did something to cause an exception, and that's I just created a new one and I threw it. Now I can also trace back to what function called that function. So here I can see that, well, this test exception was called by the main function at line 6. So if I go to line 6, sure enough, there it is, test exception. This is where I called test exception and it failed. And I can trace my way back through the code using this stack trace. So this is always good practice to kind of take a look at how to error handle and take a look at the output, because it gives clues as to what's happened. In Java, you will always encounter issues that you've never seen before, and this is good practice to kind of think outside the box and use the tools at hand to kind of figure out how an error happened. That concludes part 2 of Classes in Depth. Thanks for watching.